January 2019, question 8a, and it says I complete the table below for the function f of x is equal to 3 plus 2x minus x squared. Alright, so here we have a table of values with corresponding values of x and f of x. Two of the values of f of x are missing, and to complete this table, you'll only get 1 mark. So double checking to ensure, yes, it's only 1 mark you get for completing the table. So I'm going to try and see if I can look at it and tell what the numbers should be. I'm guessing the number here should be minus 5 because it's the same at the other end. And so we have what? Minus 5 from the left, minus 503. From the right, minus 503. We could also use calculation to check if this is correct. So we can say f of x is equal to 3 plus 2x minus x squared. So I'm going to say when x is equal to minus 2, f of x would be equal to 3 plus 2 times minus 2 minus minus 2 squared. So this would be 3. A positive times a negative is a negative. 2 2s are 4. And this is minus 4. So minus minus 2 squared is the same as saying minus times minus 2 times minus 2, which as I said is minus 4. It's sort of useful to remember that minus x squared is less than 0. In other words, minus x squared is always negative. Minus x squared is always negative. It's also useful to remember that. Whereas x squared is always positive. Alright, so this is minus 5 here. So when x is equal to minus 2, f of x is minus 5. I can then say when x is equal to 2, f of x would be equal to 3 plus 2 times 2 minus 2 squared. So this would be 3 plus 4 minus 4, alright, which is 3. Alright, so we could use calculation to find the values, but I'm thinking because it was only valued 1 mark that we could probably just put in the values. But maybe that's why prevention is better than cure. If you have space, you could always work it out. The next part of the question. Alright, II. In II, we're told to complete the grid below to show all the points in the table on page 25 and hence draw the graph of f of x is equal to 3 plus 2x minus x squared for values of x between minus 2 and 4. Alright, so the first thing we know that we're at least expecting to get a negative x squared graph, which is a frown. The graph of a quadratic function is a parabola. The parabola could either be turned up, in which case you would get a minimum turning point, or it could turn down, in which case you'd get a maximum turning point. If the number in front of x squared is negative, the parabola is going to turn down. Alright, so far the examiner has plotted some of the points for us. We're going to plot the rest. Alright, let's start off with minus 2, minus 5, minus 2, minus 5. That's the first point. So this is x is equal to minus 2 and y is equal to minus 5. A point should be here. Alright, and we should remember that when we are plotting points, we must not draw lines to plot points. So minus 2, minus 5 is here. Minus 2 vertical, minus 5 horizontal. That is 1 point. The next point is -1, 0, then 0, 3, 1, 4, 2, we just calculated it, it was 2, 3, so that comes here. All right, and I'm guessing the other points are all in. The last point, you'd have what, 3, 0, and the last point would be 4 minus 5. So let us draw our parabola. All right, let's draw the first part of it here. All right, let's see if we can get the rest of it. Now your parabola must be drawn by freehand. All right. All right. Well, not so hot, so let's try it open. All right, and let's see if we can draw the rest of it. And sometimes there's some amount of trial and error in it. The more you sketch, is the better you'll become at this process. And the last part of it. And being the perfectionist that I am, I'm trying to get it as best as I can. All right, so let's not go any further. Let's leave it there. So this is my parabola. All right. After you draw your graph, you should label it. So this is the graph of f of x is equal to 3 plus 2x minus x squared. All right. There are some questions on the graph, so let's move straight into the questions. The first question says, so this is B, triple I, or A, sorry, triple I. Use a graph on page 26 to A, determine the coordinates of the maximum point of f of x. So the maximum point is here, where the x value is 1 and the y value is 4. So 1, 4 is the maximum turning point. So I can answer triple I and say that 1, 4 is the maximum turning point. All right, so that's 1. The next question we're asked is the range of values of x for which f of x is greater than 0. So this is triple IA. The first one we just did is triple IA. So this is triple IA. So let's leave triple IB. All right, we want the range of values for x of x for which f of x is greater than 0. All right, so the x-axis is the line f of x is equal to 0. Your critical values are here. X is equal to 1. Sorry, x is equal to -1. And x is equal to 3. So those are the values of x for which f of x is equal to 0. X is equal to -1 and x is equal to 3. They're critical values. They're the values of x for which f of x is equal to 0. All right, now between -2 and 1, so your graph ranges, from what? From x is equal to -2 to x is equal to 4. And x is equal to 1, -1, and x is equal to 3 are the values of x for which f of x is equal to 0. Between x is equal to -2 and -1, the graph is below 0. Between x is equal to 3 and x is equal to 4, the graph is also what? Below 0. Between x is equal to -1 and x is equal to 3, the graph is above 0. So I could answer that says x is less than 3 while x is greater than -1 are the values of x for which f of x is greater than 0. Those are the values of x for which f of x is greater than 0. That is B. And C is asking for the gradient of f of x at x is equal to 0. The gradient of f of x at x is equal to 1. So C is asking for the gradient of f of x. So the gradient of f of x when x is equal to 1. So let's determine the point on the graph where x is 1. Alright, this is the point on the graph where x is 1. It's the maximum turning point. Alright, that's the point on the graph where x is 1. Alright, now the gradient of a curve is equal to the gradient of the tangent to the curve. Now, the tangent of a curve at a stationary point is horizontal. Alright, so the tangent of a curve at a stationary point is horizontal, where m is equal to 0. So at x is equal to 1, so I'm going to say the gradient of a curve, gradient of curve at x is equal to 0 is equal to m, which is the gradient of the tangent. Sorry, this is when x is equal to 1. When x is equal to 1 is equal to m, which is the gradient of the tangent, which is equal to 0. So the gradient of a curve at a stationary point or at the turning point here, when x is equal to 1, the point where x is equal to 1 on the curve is the turning point. The tangent at the turning point is a horizontal line. The gradient of a tangent is equal to, the gradient of a horizontal line is equal to 0. Now the gradient of the curve is equal to the gradient of the tangent. So in this instance, the gradient of the curve is equal to the gradient of the tangent m at the turning point, which is equal to 0. So the gradient of the curve at x is equal to 1 is m is equal to 0.